Hey, good morning and good afternoon. My name is Taju Joseph, an application engineer from Leap, Australia. So agenda for today, I start with the theme of this webinar and focus on three key points: design validation, mold analysis, and manufacturing. And I have a demo on each of these three topics. So the focus on these two series webinar is once you have your model ready, how you can streamline that product development and aid the production process and assist the downstream teams. We are focusing on how you validate your design with integrated solutions, then evaluate mode flow analysis, deliver clear and concise design reviews, and create high quality technical illustrations, and turn your design into reality using molding and additive manufacturing and NC machining. Best of all, Creo parametric is fully associative, and any changes that you done in the modeling will propagate the downstream deliverables. So in today's presentation, I am focusing on these three topics: the validation, mold analysis, and manufacturing. We have a second webinar scheduled for 24th of February on the remaining three topics. So the first point is validate your design with integrated simulations. Okay, so Creo have a very large range of simulation tools. Some of these tools like Creo Simulate Live is a product designer's tool, and give them guidance with the feature creations so that they can take informed decisions from the very early stages of the design. Now, while other tools like here, like for example, Creo ANSYS simulation, are more of an analyst tool, which offer a comprehensive set of capabilities to validate the performance of 3D virtual prototypes. What I'm focusing today is Creo Simulate Live. All right, so why we need it? Normally, analysis is done towards the later stages of the design, because in the industry, with other CAD system, there is no tools like Creo Simulate Live to give you instant analysis result with every geometry modifications you do in the model. So traditionally, analysis results are found too late in the process to impact the design decisions, which will slow down the manufacturing process. Sometimes analysis done using external systems and are required to export for every iterations. So design decisions are not informed decision rather than guesswork, which totally depend on the experience of the designer. So that is the reason PTC have this unique technology along with other advanced simulation tools to provide the designers instantaneous analysis result and help them with that immediate feedback when making changes to the geometry. So the solver behind the Creo Simulation Live is ANSYS Discovery, which is a breakthrough technology from ANSYS. Now, no machine required. It uses GPU instead of CPU, and CSL can do, CSL means Creo Simulation Live, can do structural, thermal, model, and fluid simulation. All right, so let me quickly show you now Creo for the first part of my demonstration. So for my demonstration today, I'll be using Polaris snowmobile dataset from PTC, but I'm particularly interested in this top cover. Some of the features and dimensions are not finalized yet, so it is still under development. I'm trying to fine tune the design. What I need is a feedback on the analysis side of the design or the design decision that I'm making. There are a couple of scenarios that I'm trying to check here. The first one is accidentally, if there is a very high force or a pressure comes to the top of this model, it can be something like somebody sit on top of it or a tree fall over it or even a big snowfall. Another scenario I will be interested is if this center road is subject to a bend, how much deformation that will cause on the model. All right, so let me open that model in a window. Got that open here. Okay, so as I said in the presentation, Creo Simulation Live is a designer tool which will give designer instant result with every single action, like creating feature or modifying a feature, modifying an existing feature in Creo parametric. We are accessing simulation live right within Creo parametric. It's not an additional module or any other external system. So I got two simulation studies already set up here. The first one is, that the load, the load I would like to apply on the top of on the surface. So that's what I would like to have a quick understanding of, resulting that load on top of these four surfaces. Maybe I will put maybe around 200 kilograms. So I'm going to specify 2000 Newton for that, and specify that magnitude or the direction of this force using existing coordinate system here, like that. Now, with the traditionally, with the analysis, as some of you which familiar with, there are lots of processing and meshing required at this stage. And even before that, typically with the traditional systems at this stage, you need to defeature the models, get rid of all the small holes or fillets. But with Creo Simulation Live, the idea here is I do some changes, I add a new feature, I'm getting an instant result here from the simulation live. So, I would like to see the von Mises stress here in megapascals. I can check the high point and the low point here, and system will straight away give me how much, stress concentration on this model. So I got 59 megapascal at the moment, which is a little bit concern for me, because if I just look at the material definition, it is an ABS material, it's a plastic material. My tensile yield stress is only 41 megapascal. So that's a high chance it will get break because it's got 59. So that will give me an immediate feedback that something not quite right. You probably need to add more material to it. Maybe you need maybe another rib or something like that. I also have another simulation study here, which is on the road which get twisted. So for that, I actually got a displacement here for 1 millimeter left and right on these two surfaces. Okay, so again, I would like to quickly check the von Mises stress here. It's around 128 megapascals here on this point. Okay, again, that's a little bit of concern for me, but I'm really interested here is the deformation, how much this model is going to deform when this bend, the center rod where it's actually get fixed, this part is getting bent. So it's around 3.29 mils, which is again a concern for me. So what I can do now is I can actually do some quick changes to my model. So let us just resume a suppressed rib which is created here previously. And you can see as soon as I do that changes, the system will automatically give me instant result, and it's reduced the deformation from 3.29 to 1.6, which is okay for me. Okay. So what about the other force which I applied on the top? Again, if you look at the von Mises stresses here, and megapascal, it was previously 56. Now it comes down to 25, which is okay based on my tensile stress. All right, so that's the whole idea of Creo Simulation Live. Getting that immediate feedback, allowing the designers to rapidly explore and find the optimal design solution, using that instantaneous analysis result. Once you are completed your design, and maybe if you like to send to a proper analyst, you can actually expect pretty much close same result. And the real advantage there is, reduce the number of iterations of analysis result. Sometimes analysis can be expensive, and you almost know what's going to get that result from. Okay. All right. Now, having done that structurally, this model now sounds okay to me. The next question for me is, what about the moldability? I know there is some slender models are here, ribs are here. My concern now is, because it's really thin, whether that will be fully filled in the mold, or if there will be a shortfall or a weld line or air traps. A lot of times the designers rely on tool makers to get their advice to check the moldability. Sometimes that only happen after releasing the part. Tool makers will come back and say, sorry, this design cannot be molded. And sometimes we get that bad news only on the first trial, and we need to actually design changes the design that also affect other design changes. you need to change the mold, you need to remachine it, it actually affects the lead time and everything else. You're more familiar with what I'm talking about. Okay, so even now we got Creo mold analysis. Before I actually show you the mold analysis, I would like to quickly show you some other tools within Creo Parametric that will definitely help you with. For example, if you're interested, you can actually check the thickness. I know there is an issue with the rib here. Okay, so it looks to me like it's a little bit slender, but I can check. Okay, is any other spaces, any other places it's actually violating that minimum thickness I would like to specify. So here I specify to have a look, minimum 1 millimeter thickness on this model and maximum 2.5. Actually put a little bit high tolerance. You can really reduce this tolerance to maybe 5 microns or 1 micron to get a really accurate result. And system will tell me now what is the minimum or maximum thickness in this model. Okay, so looking at here, I can definitely know there is an area I need to actually improve in my design so that there won't be any issues with the molding. Similarly, I can actually go and check the draft analysis, checking as the part, specifying the, mold direction. I can see if every geometry is being given proper draft. Again, looking at here, this white color tells me I forgot to actually add a couple of draft here. All right, so now what I can do is, okay, I got I got the draft already created and suppressed, just to quickly show you. And again, if I rerun that analysis here, previously it was 25 megapascal, and after I adding that draft, it will definitely reduce the thickness. It is now increased to 42 megapascal, which is again comparing with my tensile yield stress, it is 41. That is the material tensile yield stress. It's a bit a concern for me. Okay, so again, coming back to CSL, it gives me really informed decision now I can take. Because of this reason, I need to change something. That's the whole idea. Now, before I just go to CMA, Creo mold analysis, I would like to briefly explain and summarize about the simulation live and what is the whole purpose of it, just to summarize that demonstration. Now, in summary, customers achieve significant benefits using simulation live to support analysis-led design. Live simulation speed up the time to market by enabling the engineers to rapidly explore and find the optimum design. Live simulation provide immediate feedback, allowing the engineers to reduce that cycle time. And using live analysis, designs are created right from the first time, eliminating that costly late stage rework.